Today we're going to continue with the idea of situations where you are given a point and a slope. So it's the same idea as point-slope form from yesterday, but the difference today is we're going to apply it to a real-life situation. So your objective, your goal for today that you are writing down, says I will be able to write the equation of a line and find its domain and range to represent real-life situations. Oh no, domain and range have reappeared again in Unit 2. So we are going to apply everything we've learned in Unit 2 to real-life situations and throw in domain and range. As soon as you have your objective written down, move on to the next slide. Here's the example you're going to write. This whole set of notes is all for Shelby's cell phone service bill. We're just going to ask questions A through I. There's going to be a bunch of questions all about Shelby. So here's the story I would like you to write in your notes. There is a monthly cost for Shelby's cell phone service plus an additional 50 cents per minute she uses it. Her cell phone bill costs her a total of $51 on a month that she happened to talk for 42 minutes. So take a moment, pause the video if you need to, and write that story down. When you're ready, we're going to go ahead and get started and identify our independent and dependent variables. If you remember earlier this chapter, we have been talking about independent versus dependent. And remember, we have said independent, which is our x, is almost always the time. Because that is independent, time goes on no matter what. The question is, what value depends on the amount of time we talked? Well, what matters is the cost. So our dependent variable, our y, is going to be the cost. So let's go ahead and look at some information up here. Her cell phone service bill charges 50 cents per minute. Anytime you see this per word, that is generally your slope or your rate of change. Her cell phone bill costs a total of $51, that sounds like a cost, when she talked for 42 minutes. That sounds like time. So make sure in your notes you're writing A, independent and dependent variables, and then write this down over here. Our M, our slope that we just talked about, our rate is 50 cents per minute. The ordered pair that we just created below is the point 4251. Oh, look at that. We have a point and a slope. Anytime we are given a point and a slope, we generally go to point-slope form. Once we're in point-slope form, we can then convert it to slope-intercept form. So go ahead, take a moment if you need to pause to write all this down. We've got our independent and dependent, which created our slope and our ordered pair. We're going to now write down the formula that we need, y minus y sub 1 equals m times x minus x sub 1. So if we sub in the values that we were just discovered and we found in our problem, y minus the y coordinate was 51 equals the slope, or the m, was the 50 cents, that is the rate that she is being charged per minute, times x minus x sub 1. Well, our x sub 1 was 42. That is in point slope formula. We want to end up in slope intercept form. So what we're going to do is keep our y minus 51, just like we did yesterday. On the right side, however, we're going to distribute. 0.50, or 50 cents times x, is just 0.50x. Now 0.50 times 41. Don't panic here. 0.50 is like a half of a dollar, so half of 42 is 21. That's a negative times a positive, so that'll be a negative 21. So make sure you're okay with that. Half of 42 is 21. Now we would like to isolate the y, which means the minus 51 needs to go away. So we'll do the opposite, plus 51. Because negative 51 plus 51 is 0. So there's my y equals. Remember, we are not doing anything with the x term. But if I did plus 51 on the left, I need to do plus 51 with its like term on the right. Negative 21, positive 51, there are more positives. How much bigger is 51 than 21? It is 30 bigger. So if we were to write this equation in slope-intercept form, it would say y equals 50 cents times x plus the $30. Now that should kind of make sense. We have a one-time fee of $30 plus we pay 50 cents times however many minutes we talk on our phone. So take a moment, make sure you have all of that written down for A, B, and C. When you have all that written down, go ahead and move on to the next slide. We are going to take that equation that we just created, it's right here, y equals 0.50 or 0.5x plus 30. We are going to set up a table. Now, because we don't really just talk for 1 minute, we're going to kind of go by fives here, 0, 5, 10, 15, and 20. So what we're going to calculate now is if I have my 0.50x, I'm going to sub in the 0 and then add 30. So what I'm doing is I am subbing in the values just like we did earlier this unit and last unit. Subbing in for the x, multiplying, and then adding using our order of operations. Well, anything times 0 is 0. 0 plus 30 is 30. So even if Shelby talks 0 minutes, she still owes $30 because there is that one-time monthly fee. So now let's see what happens if she talks for 5 minutes. We will sub in the 5. So you're going to evaluate 0.50 times 5, which is 2.5 or 250. So we got 250 plus the 30 means if we talk for 5 minutes, Shelby's bill is going to be $32.50. So go ahead, take a moment, fill in the remaining values, subbing in for each one. Come back when you're ready and check your math. So take a moment. Did you notice a pattern? After we subbed in the 0 and then the 5, did you start to notice a pattern? It went from 30 to 32.50, from 32.50 to 35, and then it went from 35 to 37.50. It is going up by $2.50 for every 5 minutes as time goes on. So it's essential that you have these values. We have the 0.030, the 0.5, 32.50, so we'll do some estimating in a minute. And then we have when x is 10, y is 35, when x is 15, y is 37.50, and when x is 20, y is 40. We are going to take those values now for letter E and we're going to graph them. So make sure you have this table filled in. So we're going to start at 0 minutes costs us $30. Well, before I can even start graphing, we've got to decide which one was our independent x. If you look back at your notes, independent is time because time is always independent, time goes on. So please label your x-axis as time. Now your cost is what depends on the independent. So our cost depends on our time. So take a minute, set up your graph, and then let's get started graphing. When time was 0, Shelby pays $30 no matter how many minutes she talks. After 5 minutes, it was $32.50. Well, that's halfway between 30 and 35. 10 minutes, it went up another $2.50, so she was at 35. 15 minutes, we were at $37.50. 20 minutes, we were at $40. 25 minutes, if you see the pattern here, we could continue. Once you have your points, go ahead and connect the dots. Make sure you put an arrow on the end because she could continue talking as many more minutes as we'd like to label our x-axis out. It's not going to just end. It is a ray with an arrow on the end. Once you have a nice, neat graph with the independent and dependent variables labeled, it has got the numbers for the scales and graphed. You can move on. If not, pause your video and get your graph nice and pretty. So taking the same information for this equation, what does the slope represent in real life? Yes, the slope is 0.5 or 0.50, but what was 0.50 if you go back to the original problem? So to identify the slope is 0.50, that is how much money she paid per minute. So when we see 0.5 in the equation, it's not just some random number. It totally applies to Shelby's situation. It's the 50 cents she pays per minute. So take a moment, write the question, and write your answer. The next question is, what does that y-intercept represent in this situation? Well, remember, the slope is attached to the x, the y-intercept is here on the end. So yes, the y-intercept is 30, but what does that mean for Shelby? What does she care about the 30? Well, the $30 is her one-time service fee. So the y-intercept of 30 is the service fee. So part of today's lesson is not just can you write an equation and graph it, do you actually understand what it means in context of the situation? So the slope is the rate that she's paying per minute. The y-intercept represents her starting cost, her one-time service fee. So once you have those written, feel free to move on to the next slide. The next question is the domain and range, and then we will be done with Shelby's problem. Now think about domain. If you were to try and quickly picture your graph, you probably have it on your paper. Domain was your x, which was your time. So what's the least amount of time that she can talk? 0. What's the most amount of time she can talk? Well, we don't know. She could talk forever as far as we know. So that domain should look like 0 with a bracket to infinity. The last question before we are done for today is the range. So go back and remind yourself, domain or the range was the cost. What is the least amount of money she pays? What was this number, this y-intercept? What amount does she pay even if she talks 0 minutes? That amount that she pays, part of her range, is 30. And then since she could talk for as far as forever, for minutes, her cost could also go on as forever. So the range, which is her cost for her bill, the cheapest she can get away is 30 bucks, but we don't know how high it can really go, so we're going to say infinity. Once you have all of this down, you are complete with today's notes. So are you able to take a real life situation, find the point and the slope, and then be able to write the equation to represent it, as well as answer some questions like the domain and range of that real life problem. If you feel comfortable and confident, then you are good and done. If there's anything you'd like to review, feel free to go back and double check it out.